Good morning. It's Friday morning. Weekend's right around the corner. We're doing some more adding and subtracting of rational expressions. Remember, the first thing we need to do here is factor the denominators so we can get a common denominator. So looking at these numbers here, it looks like -3 and -2. -3 times -2 is 6. -3x and -2x is -5x. X and x is x squared. All right. Factoring this, we have the difference of two squares. So we have x plus 2 and x minus 2. Okay. Now that we factored the denominators, we want to get a common denominator. So remember, we're going to pick all the unique factors. So we're going to start with x minus 3, x minus 2, x plus 2. We already got x minus 2, so that we don't need that one. So this is going to be our common denominator. Okay, so we had the x minus 3, we had the x minus 2, and we needed the x plus 2. So we're going to multiply 3 by x plus 2. On the other side, we needed the x minus 3. So we're going to multiply by x minus 3 on top. We have the x minus 2 and we have the x plus 2. Okay, now that we've done that, we're going to go ahead and simplify the numerator. So here we're going to have distribution property going on here. So we have 3x plus 6 plus 2x minus 6. Combine like terms, 3x plus 2x. 6 plus -6 is 0. And that's going to be over our common denominator. And we're done. No simplifying to be done here. Okay? Let's take a look at number 2. Number 2, first step, we need to factor the denominator. Factor the denominator. Okay? So what I did is I started by multiplying a times c, and then I put my b on the bottom, and I could not factor this. But I did notice that each term is divisible by 2, so I went ahead and factored out a 2 out of each term. So 2 goes into 2 once, 2 goes into -6 -3 times, 2 goes into 18 9 times. Okay, and this is not factorable. Then over here we have the sum of 2 cubes. The sum of 2 cubes. So remember, to factor this, I needed to put them both in this format. And then this is A and this is B. So x plus 3, then x squared minus 3 times x plus 3 squared. Remember, the formula goes like this. And that's when you have the sum of 2 cubes. Okay? And this is the sum of 2 cubes. So I took and put it into this format. Okay? So, getting a common denominator. Do that right up here. Okay, we need a 2. We need an x squared minus 3x plus 9. We need an x plus 3. And we already have that. Okay, so for this numerator here, we already have the 2. We already have the x squared minus 3x plus 9, but we need the x plus 3. For this numerator here, we already have the x plus 3. We already have the x squared minus 3x plus 9, but we need the 2. So we're going to have 2 times 2x plus 6. Okay? And that's going to be over our common denominator. Okay, so now that we have a common denominator, we need to simplify the numerator. So let's do it right above. Distribute 5x plus 15 minus, distribute the 2, so we get 4x plus 12. Notice I kept it in parentheses because we're subtracting a group. So we're subtracting both terms. So 5x minus 4x is 1x. 15 minus 12 is 3. And then we put that over our common denominator. And we have a group on top that matches a group on the bottom. So they can cancel. There's nothing left on top except a 1. Because anything divided by itself is 1, 1 over 1. And there we have it. Okay, let's take a look at number 3. I started off by factoring our denominator. Okay, now we get a common denominator. So we need an x plus 1. We already have an x plus 1, so do we need it again? Okay, do we need it again? Yes, because these two make this, and we definitely need this in the denominator. Okay, we definitely need both of these. Now, do we need an x plus 2? Yes. Do we need an x minus 1? No. No. So, when they're the same factors, but they're under the denominator, under one of the fractions, you're going to need to have both of them. So there's an exception to the rule. Where we do need the same, when it's underneath one of the rational functions. Okay, one of the rational expressions. So, over here, we're going to use x minus 1, and x minus 1, and x plus 2. Same as this one. So all I did was I dropped these two down, and then I included the x plus 2. And once I've built this one is the same. Okay? So, this side, we have 1 times, we needed the x plus 2. Okay, on this side we have x plus 1. Now we have an x minus 1, but we need another one. And we have an x plus 2. Alright, let's go ahead and move back up here now. And let's go ahead and do some simplifying here on the top. So 1 times x, 1 times 2, we have x plus 2. We're subtracting a group. This is going to end up being a group. So if let's FOIL it, first terms, okay, inner and outer cancel. Last terms is -1. Over our common denominator. Okay, so this is going to be -x². This is going to be +1. And a +1 and a +2 is a +3. And then we have an x. So I'm going to put the x first and then the +3. So I put the -x² first, I put the x second, and then I combine the 2 and the 1 to get 3. Okay, so right here, that's my final answer. I did try to factor the top using my x factor. It does not factor, so that's my final answer. Okay? Alright, back to multiplying and dividing. So remember, when multiplying and dividing, we factor everything, and then we do some canceling. So I went ahead and factored out well, actually, this is the difference of two perfect squares. So I did 2x² + 2 and 2x² - 2 to get that. And then I went ahead and did the x factor and factored that down here. And then I changed division to multiplication. I moved the 2x to the bottom. And then the 3x - 15, I factored out a 3. And I got that. Times. And here I factored out an x out of both terms. And I got x + 4. Here is a factoring by grouping. So I grouped the first two. I grouped the last two. Here I factored out a 2 out of both terms and an x² out of both terms. So I got 2x², which left me x - 5. Okay, plus, and I factored a 2 out of both terms, which left me an x + 5. And then I regrouped these so that the 2x² goes with the 2, and then the x - 5 goes here. So I don't need that anymore. If you need help with factoring these, please see me. Be specific. Hopefully, I don't know how to factor any of these is not your question. Hopefully it's, could you go over the factoring by grouping again? Or I'm not sure how you got this. Can you go over this again? That's a specific question. Okay? Now we're going to go ahead and do some canceling. Well, I see a 2x² + 2 here and 1 here. An x - 5 here and here. I see an x + 4 and an x + 4. So I'm starting off with my groups. And I think that's good for groups. Now let's look at terms. 3 and 2. Nope, can't reduce that. 3 over 2. X and x. Yep, those two can cancel. So on top we're left with 3 times 2x² - 2 over 2 x - 1. I see something. I can go even further. I just noticed it. Does anyone else notice what I could possibly do to factor this even further? Let's see. Let me know in class what the final answer is. Okay? Thanks. See you guys in class. There will be a quiz on Tuesday. There will be a quiz on Tuesday. There will be a test on Thursday. Quiz Tuesday. Test Thursday. Over adding and subtracting rational expressions, multiplying and dividing rational expressions. See you later.